Hey, hello, and welcome to the show. It's me, John Park, and it is time for John Park's Workshop. I caught myself off guard because I think that intro song segment I picked is shorter than it used to be, so I was just over here cleaning my glasses, and suddenly the show is starting. Hello! Howdy over to the people joining in the YouTube chat. Hey there. Oh, wait, do I have a... No, I don't have that up. Hello to Dave Odessa, Johnny Bergdahl, hello. Beata Graf Avdalhagen, howdy. We have I do have a little Discord button right there, and thank you for joining over in the Discord. Paul Cutler, Liz, Blitz City DIY, Johnny Bergdahl there as well, Jim Hendrickson, Thinman, C. Grover, hello, and it's me, JB. Nice to see you, JB. What was I about to say? Couple people in the chat there. Okay, that reminded me, that jogged my memory. I did not want to forget, since I saw Paul Cutler there in the chat, that this right here happened. It's the CircuitPython show. If you don't know about that, that is a podcast run by Paul Cutler, and I got to be a guest on the show on an episode that just launched yesterday. So head on over to CircuitPythonShow.com and you'll see it right there. I think I have that up in my browser. Let's find my browser. Sure, yeah, look, this is it right here. If you head on over to CircuitPython Show, you'll see there's a link right there. Lots of great interviews on this that I've listened to over the couple years now that Paul's been doing this, along with, if you actually go back a level on CircuitPython Show, you'll see that you can also get to the Bootloader podcast there, which is the monthly podcast with our good friends Paul Cutler and Todd Kurt. So go check out both of those podcasts. They're terrific. I really enjoy them, and it was a lot of fun to chat and be on the show. So thanks for inviting me to do that, Paul. And let's see what else. What's going on today? I've got a coupon code for you, so you can save some money in the store. I've got a recap of my Tuesday show, the product pick of the week. I've got a fresh new CircuitPython Parsec brought to you today by a suggestion and example from C. Grover, our good friend C. Grover over in the chat, so thank you. What else? I've got some gear report type of thing, retro tech type of thing, a little minor project update. I even have a recap of a Learn guide that just came out. In fact, it's so fresh and new, I have not yet blogged it. I need to get on that. So those are some things to look forward to. Let me go ahead and get going with the coupon code. So look, that right there, CTech Astronomy, SETEC-Astronomy. CTech Astronomy is the coupon code today. That is good until midnight tonight, and will get you 10% off in the store. So head on over to the store, type that into the coupon code slot on the way out. You'll save yourself 10% on physical goods that we can send to you. It does not work on software or gift certificates or subscriptions, but it does work on physical things. And if you head over to the shop, still getting used to my icons, that right there, head on over to the shop. We've got some new stuff here, a bunch of new sensors to check out, and more. So if you click on this view all new products right here in the shop, you'll see some snazzy stuff, and you can get 10% off on pretty much all of it just by using that coupon code right there, CTech Astronomy. Why CTech Astronomy? Well, if you check the socials, PT Phil Terone, our very own Mr. Lady Ada, is cooking up some interesting stuff, and I got involved with it. All I'll say is that it's a reference to the movie Sneakers, so you might want to go back and rewatch Sneakers if you want to uncover the mysteries of what's going on with CTech astronomy. So that's all I'll say about that. That's actually not the only thing I'll say about that, because my little retro tech we're going to do today also involves a prop from that movie. But before we go on with that, I will talk to you about that. That is the show. Look at my perm. That is the show on Tuesdays, which is the product pick of the week show. This week it was these half-size Perma Proto PCB breadboards. I love these things. And on that show, I've usually got a 50% off deal during the show. Thanks to the new products team for making that happen every week. We stash a bunch of them. We cut the price in half. We let you buy them during the show. No coupon necessary. During the show, you get them at a sizzling hot discount. Here was the recap from this week's product pick. The PermaProto half-size breadboard PCB. Solder your wires down and know that they're not going to pop out. So this is one of my favorite ways of prototyping. We've got the sort of numbered rows here, 1, 2, 3, 4, 5, and on. We have power rails on the side, which are marked with this blue and this red. Those are our ground and power rails. So you can break those out from, say, a microcontroller and then use them throughout the rest of the circuit. You can take a hobby knife, cut a trace there, and then make some extra little smaller sets of circuits, sets of 2s and 3s. I've got these little short headers on here. You just solder those up. This is great because if you do have a QT Py, maybe you're always wanting to have a button and power, you can leave that stuff on there and then you can swap out different QT Pys. A really convenient little way to go beyond the prototype, really. Half-size PermaProto breadboard PCBs. Yeah, it is. I thought that was about to loop because I said the last thing very similar to the first thing. It's like, oh, did I forget to tell that video not to loop? No, just fooling myself. So we will be taking actually a little closer look at that. I did not have Fritzing installed during the show. I wanted to show you this layout on the one button, continuing on with the one button keyboard project for the prototyping stage, and then I'll be going into a different arrangement of those for the real deal on the one button Bluetooth keyboard. However, before we get into all of that, let us jump into the CircuitPython Parsec. CircuitPython Parsec. All right, I just need to get Zed out here. Hey, Zed. All right. It's good to go? Yeah, I think it is. For the CircuitPython Parsec today, I wanted to talk to you about using a modulo operator for neopixel indexing when we wrap neopixels around a ring or a strip or another arrangement of neopixels. This, of course, is a broader topic than that, but we're going to focus on that specific example. So first thing I'll do is let me kick this demo into gear. So you can see I've got a little 16 pixel neopixel ring here connected up to a Feather RP2040 prop maker, which has nice convenient screw terminals there for neopixel output. But this would work with any arrangement of neopixels coming off of a microcontroller in CircuitPython. And what I have going on here from the imports, I'm bringing in, actually this random doesn't even matter, I'm not using that. I'm importing time, I'm importing the board for the pin definitions, I'm importing NeoPixel, and I'm importing digital I/O so I can turn on the NeoPixel power pin, which is sort of specific to this board. You usually don't have to deal with that. I now have a variable here called pixel count for the number of pixels that I'm dealing with, a speed, how quickly these revolve around, and a little pause that I can use just in demonstration mode to show how these pixels are wrapping around or moving around the screen. We have a little class here called color that is a set of NeoPixel color values for RGBW NeoPixels. That's why you'll see there's 4 different values there in hex. Next thing I do is I turn on my external power so that we can turn on the NeoPixels themselves. This is just a power saving option on the prop maker and the prop maker wing so that we don't always keep that pin active. So the next thing I'm doing here, I am setting up a NeoPixel strip called Pixel. And this is with NeoPixel board external NeoPixels pin, which is the one on that little green header, the pixel count, the pixel order, which for these are the RGBW pixels, red, green, blue, white, but they're actually arranged green, red, blue, white as far as how we talk to them. And I have auto write set to true. Then I'm setting up a brightness value and I'm filling them all black. So if I restart this, you'll see we're going to turn them off and then turn them back on and start spinning around here. So in the main loop right now, you can see it's actually kind of an elaborate long bit of code. This is a conditional if statement approach, which we're actually going to make this much neater and shorter with the modulo approach. But starting off with what's really happening in here. Let me slow this down. So I'm going to set a pause of half a second between pixel lighting operations. So you can see pixel 0 lights up, then the one in front of it and the one behind it, or rather behind it and in front of it. So the green pixel is the index that we're tracking. And if you look in my code here, you can see we're on pixel 5, pixel 6, pixel 7. So what happens is when that green pixel advances, we then want to light the previous one red and the one in front of it blue. The problem is this is a 16 neopixel ring, so it goes from index 0 up to 15, but there is no 16th, 17th, 18th, 19th, 20, and so on. So we can't just keep counting up. We'll just sort of fly off into space where there are no neopixels. So what we need to happen is check in the sort of traditional code here when we run through the range of neopixels, starting with 0, and that's what this I stands for at the beginning. If I minus 2 is less than 0, then we're going to add the pixel count to that so that we can deal with the one in front of it without running off into negative numbers. And then we do the same in the other direction. If we're at pixel 15, there is no pixel 16, so we have to subtract the whole number of neopixels there and add that, that number to the index that we're choosing. So what I'm going to do is I'm going to take these like 30 or so lines of code and I'm going to hide those, comment those out, and then look at this nice little neat version of it. I'm going to uncomment that. Save that. You're going to see it's going to operate exactly the same way. So we light 0, then 15, then 1. We light 1, then 0, then 2, and so on. The way this is done is with the modulo operator. So here you can see for I in range pixel count, pixel I minus 2, so at the beginning that's 0 minus 2, negative 2, but we're going to use the modulo operator, which just is going to divide that by the pixel count and give us the remainder. So that remainder is going to be, in this case, 15, and the one in front of it is pixel 1. And so you can see here we blank that pixel, we light the next pixel, so green moves to the next one, and then I'm pausing. Then we light the one in front of it to red, and the one, the behind it to red, and the one after it to blue, and continue. So this is much simpler, much neater, easier bit of code. You can see if I tell it a different value of pixels, let's say I'm going to get rid of my pause here, and I'll pretend there are just 8 pixels. This will work the same, it's just the modulo operation is now going to work with 8 instead of 16. So whenever we get to pixel 7, we're gonna wrap around to pixel 0 again and keep that relationship between the first and the last. And so that's how we can simplify the code and reduce it much more elegant, I think, using the modulo operator versus a bunch of if-then statements. And big thanks to C. Grover for showing me this example. He was using it in some code for something he was building and said, I think this might make a nice parsec. And I agree. So that right there is how you can use modulo to wrap your neopixels around a ring. And that is your CircuitPython Parsec.
CircuitPython Parsec.
All right, good. Are we? Yes, we're back. Okay, still getting used to my new buttons that I press. So over in the chat, let me bring up the chat here. Todd was just saying this modulo example is also showing some Python array magic at the ends of the neopixel array, because the code at that time does pixel -1 equals red, which would cause Arduino, and C conniption fits. Yes, there's a lot packed into that example. Check it out, try it out, and try changing some values around, playing around with it to see what you can learn from it. So yeah, thanks again. Shout out to C. Grover. All right, let me get that out of there. Let's see. Next up, let's do a little Learn Guide recap. Head back over to my browser here. And this is the new guide for the Espectre human detector for Feather. First thing I'll do is let me just show, I'll just play this video here. I don't know if I can easily mute that. We'll listen to it as well. You know what, let me open it on YouTube. There, I'll have a volume control. Sure. Okay, so you can see here, this is the boot up of the little ESP32S3 Feather reverse TFT. It logs in, it finds my router, and then it is throwing packets at the router and watching the CSI values to see if they change, if there is noise. If there are noisy redirects around the human in the space, then it, after a certain threshold, says, okay, someone must be moving. Now, interesting thing in this demo, let me pause right here. The router is actually opposite direction of me. So even though the human body, is not between the router and the antenna on the ESP32S3, it still affects that, probably through reflections and things, but it still affects that the radio waves of the communications between the two. So that's one of the really interesting things about this, is it's sort of omnidirectional within the constraints of the antennas. And it is not using any kind of light or ultrasonic, so it works through walls. So if you put a barrier, enough, Wi-Fi goes through a lot of types of walls. You might not get through plaster and lath and chicken wire mesh and stuff like that, but in most indoor household kind of situations, you can tell between walls if there's human motion. Now, this does not detect a still body. It's not like it's infrared or something like that, but when there's movement, that's what interrupts those radio signals. So really neat, I think, sort of proof of concept of this. Obviously, in this case, I'm just displaying it on the display, but you could imagine using this to set off an alarm of some kind, to run a script, do a I/O kind of thing. In the original project that this is based on, Espectre, this was for some home kit kind of stuff, to get ESP Home to change the lights or the volume or the temperature based on someone being in a room. So those are some of the core concepts there listed at the beginning about this signal processing pipeline. And then I've got a little 3D printing there. If you want to, you can print that case. It's a snap fit based on a Ruiz Brothers design. And then you can use the little antenna adapter there to screw that in and add your antenna. Either antenna works, the larger or the smaller gain Wi-Fi antennas that we sell, 2.4 gigahertz antennas that we sell. And I did not test if there was a situation where I needed to be farther away and could use only the bigger antenna. I mostly was testing in here, and the space is small enough that I didn't need the bigger antenna. There's your mounting. There's the little threaded connector. Screw on the antenna, and you can move that to wherever you need it to be. Let me just walk over here for a second and grab it, because I have it sitting back here. One of the nice things about the design of these antennas is the orientation is not dependent on screwing it in. So you screw it in with these little knurled threads right here. If I can keep that in focus, it still freely moves in there. Has some sort of little like commutator. So you can set that vertically. You can set that on a desk. You can point it out this way, however you want. And you're not unscrewing that when you use it, which is very nice. Then I've got a page here on the Arduino IDE setup for using ESP32 stuff with Filhauer core, and a couple of libraries you'll need to install. Here is a little bit about cloning the repo so you can get all the files that you need. You will make one change, which is there's a config.h, which contains your Wi-Fi SSID and password, so you'll need to change those. Then you can test compiling it with your board settings. All the board settings are listed here. Libraries you need are ST7789, which is the driver for the little TFT display on here, as well as Adafruit GFX for drawing stuff, and NeoPixel. Everything else is part of the core. Compile it, check some settings on here, and then upload it to the board. That's the main Arduino code right there, but there are a lot of support files as well. And then here's a little bit about using it. So there's the boot up. It goes through a little display color sequence, just so you know the display's working. Espectre CSI motion detector, Arduino edition, connects to your Wi-Fi. You can see there the IP address as well as the signal strength. And then we should get gain lock, and it'll tell you that it is ready. And you don't want to move during that part. That's when it's going to gain some baseline values for the radio waves. Then once it says idle, it's ready and you can move around. And when it detects enough variance in that CSI value set, you will get your threshold tripped, and you can adjust that in code if you want to as well, and it'll tell you motion. And then I added another page here to what the porting process was like, since I used Claude code in a terminal I took a clone of the repo, I pointed it at it, and this is all of the prompts that I used and the responses. So if you're thinking of doing some Claude code or other LLM-based porting, this might be interesting to you. You'll see it trying stuff. It's pretty good about, I told it in the sort of planning stages to have me do tests and then send the serial output based on those tests. So there's a lot of back and forth there when things are working and not working as it figures it out. So didn't take too long. It's a couple of hour process, and in the end we got that result, which I think works really well. So that is the Learn guide for that, and let me know if you try that out or run into any issues. Let's actually jump to a different page. I saw a question in the chat, YouTube chat, from Peter Huseman 3956 asking about the prop maker feather. If you type in prop-maker, you'll see we have a few things. There's the prop maker feather wing, which you can add to pretty much any feather. There's the a version with and without headers for those. And then there's this prop maker feather that says RP2040 in it. So that's not a feather wing add-on, but that's both the RP2040 based microcontroller and the prop maker fixins. So you can see there it's got your usual stuff, USB-C, battery circuit, the RP2040 little I2C stemma QT header on there. Then there's a few extras that are visible right here. We've got this set of headers, and those are for 5 volt out for NeoPixel, ground, NeoPixel data out. There's a pin for a button, just generalized, hey, I want to put a button to ground and input and use it externally. Little clicky switch kind of thing you can imagine for props, making a lightsaber or doing a costume thing. And now I can't remember what the other one is. If I flip this upside down, let me go to a full screen image of that. There's a button, and then the speaker output. So there's a 4 to 8 ohm speaker amplifier, so you can do some external sound stuff. And this has, you can read on the silk screen on the bottom, that's a 3 watt amp, I2S amp. There is a servo header, so you see on the bottom here, ground, 5 volt, and servo. If we go back to the top view, of this. You can see a little set of little copper dots there behind the green header. Those are three. I could just get this one out. How about those are three little. Turn on another light. There you go. These are three little headers here for putting a servo into. This also has, I think, an accelerometer. What else? Yeah, triple axis accelerometer. It's a LIS3DH, so you can do tap detection, single or double tap stuff on it. And more, and these are great. And I was reminded of these because there was a new project that, if we go back to Learn Guides for a second, this Close Encounters of the MIDI Visualizer kind project that Noah put together. I think this used that. Yeah, I was helping review this guide, and I saw that he'd used that prop maker feather, and it's such a nice one because if you're trying to do a no solder project, the fact that you can not add headers and put it onto a breadboard or anything like that and not have to solder NeoPixel wires, you can just cut them and strip them, twist them, and screw them into the terminal block, is super nice. In fact, here's the little wiring assembly here. Cut, strip, and put them into the board there. Actually, I think he did some soldering just to make a nice silicon wire extension cable, but you don't have to. You can get away without any soldering on that board. Yeah, so that's that board. I like that one a lot. Okay, now I want to talk about this one key project. I'm just going to add a new screen cap here for Fritzing. Sorry, I had to close this and reopen it. So let's do new screen capture, config, window. Actually, let's call it game. That gives me nice fast interaction. Okay. In front of there. There we go. Okay, so this is the diagram I used to get to that for my PermaProto demo. So you can see I've got the ESP32 CircuitPy, a clicky NeoKey button with NeoPixel BFF, and the LiPo BFF. These are made to be put bottom to bottom, and it works either with just a pair of them, CircuitPy and the BFF, or you can use stacky headers, which I don't think I have any right here, but the long headers to do like a stack of them. And that's ultimately what I'm going to build for this, but I wanted to put it on a breadboard, and since these are not, the BFFs are not really meant to go on a breadboard in the same arrangement as the CircuitPy, you kind of have to do flip it upside down in your head, and that's a great way, for me at least, to get things terribly wrong. So instead I decided to Fritzing diagram that out, and that is, if you look here, that is what my wiring, why my wiring crosses over. So I'm not doing the full set of pins here for everything. I would recommend, actually, there's a PCB that Liz designed that gives you a BFF and one CircuitPy and 3 BFFs, and all of this sort of rearranging of the wiring has been done for you. So it allows you to have a little carrier board and pop all 4 on there. But this is just a limited version of that idea that I tested on a breadboard and then put on a PermaProto. And so you can see I'm just running 5 volts over to this, where the 5 volt will be on, most importantly, the LiPo. And since I can't use these on a breadboard without everything kind of being backwards and confusing to me, I just used some header strips here to keep things straight. And then you can see underneath I wired from 5 volt to 5 volt and ground to ground. So that's what got me to that right there. However, next step will be doing a stacking arrangement of them. I'm going to try to keep it as tight as I can because I'm going to put it into a little 3D printed case I'm going to design so that we have just a single button with a USB port for charging and access to an on-off switch. Nice thing, the LiPo Power BFF has a built-in power switch, but it also has header pins for ground and power so that you can turn it on and off from an external pin so that I don't have to worry about the one that's kind of buried under there. So I may be able to use that, or I may be able to keep things upside down and enough out of the way that I can have it accessible from the bottom. We'll see. And if you're new to this project, what am I even doing? This is a one-button Bluetooth keyboard, and I'll be showing how to do single key press HID stuff as well as macros on there. I may get ambitious and try to do some boot menu stuff. So if you're holding it down when you turn it on, it'll go into like a selection menu using color coding. Maybe give you 2-3 options of what your which script you're going to run when you press it. So that's what that project's about, and that's the fritzing for it. Here's the schematic, which I only did for one of them. I didn't, since I have a duplicate on there, I didn't do it for the second one, but you can see one thing I really like in fritzing, if I'm doing not making a PCB, but I'm doing a breadboard thing or a permaproto thing, is actually to color code the schematic wiring as well as the breadboard wiring. I'm most likely in this case to have built it first in breadboard view, but then I'll connect it all up in the schematic view as sort of a double check. I think these are also really helpful for people who want to follow the circuit and aren't necessarily using fritzing, but if you want to take this and bring it into KiCad and do your own version of it, it's nice to have a schematic. It's nice and clear what's connected to what. So that is how I'm using fritzing for this. And let me know if you have any questions or thoughts about that in the chat. Nice suggestion over in Discord for the proximity detector, Espectre, is add a speaker and a dog barking wave file or two to the proximity detector. That'd be good. I like that. Especially because it works through walls. Next up, I want to talk about, so I built this prop that Phil, PT, Mr. Lady Ada, requested, and so I'm going to leave the unveiling of that to him, but it involved gutting a old answering machine, and he didn't need the guts and they weren't working, so I kept them, but then I got them working, and so I thought I'd show them to you. So let's run over to the bench, and I'll fix that arrangement of things a little bit. Get some more light on here. A little brighter. Good. Sorry about the camera wobble. All right, so let me move this over here. So this is the answering machine this came from. This was a Panasonic KX-T1450 EasyPhone with auto logic, automatic telephone answering machine with remote control, and it uses dual standard cassettes. So a lot of answering machines used the little mini cassettes or micro cassettes. This uses standard cassettes, which is kind of neat. I presume that gives you longer length at higher quality just because you have more thicker tape, more room for it. The longer a tape has to go, the thinner the material is. But there it is. There's also probably an evolution of these just to get them smaller, and so at that time it was pretty big. And let me unplug this first. So when I got this tape head here was stuck in the down position, and so this tape couldn't be removed. This one could, just lift it out, set it out. This one would not remove because this tape head was stuck. So I pulled it from this system. I tried running it, and I heard it click, 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 clicking a little solenoid, but it couldn't engage the gear necessary to move this tape head out of the way, the whole mechanism out of the way. So we have a tape head and a race head and a little roller, capstan roller. If you flip it over, it's just all circuit board. But look at this great design. They just made a easily serviceable header pin connection sandwich between the two boards. Oh, that was just a little volume slider that slid off. That's okay. So you can see here we've got these header pins and female header connectors here and here connecting up. I haven't looked to see kind of what's connected where, but some of this is going to be power, and some of this is going to be some I/O logic stuff. Some of it's going to be sensors that are built into the mechanism. And this was our problem. This belt was shot. It was so had no elastic left. It was moving, but it wouldn't turn some of these pulley heads here, and so it was failing to engage the mechanism. If I move, this is the motor over here. If I move this, you can see, should be able to see even that one there. They're all moving just on friction and tension of that band. And when these are engaged and it's running, part of what it's going to do is turn this gear to allow these solenoids to click into place to use them or not, to try to direct this. So that was an easy fix. Now, that's not to say there aren't other things that might be wrong with it, but so far I did a couple of tests and got it to play back and record. So we'll see what shape it's in right now. Let me reconnect this here. And oh, we missed. There we go. This one's not engaging now. Let's see. Or does it only go in that far? Ah, it's just tall. Okay. Yeah, that looks good. So plug this in to power. And I think even without tape in, I can get some of these mechanisms to work. So let me just, I'm just going to open up Discord on here to make sure everything's working. I do have actually turn this off. Actually, let me turn off the HVAC. I don't need it as much. So let me open the Discord. But I did just want to check if the mic sounds okay. No screaming yet. Okay. Oh, close that. There we go. So the case is gone. It's in New York. I sent it to Phil. The buttons, however, are labeled on the PCB. So if we do something like rewind over here. Oh, let me turn it on. Oh, you can see there, it just engaged. And this is the thing that I think is fantastic. Let me turn this off. I'm going to put the cassettes in now. Rather than duplicate a lot of the mechanisms here, you never need to play the outgoing message at the same time as you need to do something with the incoming message tape. So these two tapes, if you're not familiar with this old of a... oh, here's a little spider. Come here. There you go. When someone called the answering machine, a message would say, "Hey, this is John, please leave a message." That message was on this tape. Later, this became a solid state thing. And so you would have a short message that was built into a little solid state memory chip. The incoming message would still often be on a tape just because the amount of time someone can leave a 2-minute message, or if you have the thing switched to never stop someone, they can go for 30 minutes until the tape stops on that side. But this predates that. So here we had an outgoing message. This is a 15-minute tape here, which is kind of neat. And this is the incoming message, which is a 60-minute tape, which is what was on here. So the need to use these but not have, you know, 2 sets of motors and gears and all that means that they came up with this design that just shuttles this mechanism up or down depending on which one we're going to use. So if I turn this back on, first thing it does is it rewinds the outgoing message tape, plays it for a few seconds. I don't know if it senses the tape leader. I don't think it does. I think it's just a set time. But it gets that to the exact point where outgoing message would be. I'm going to hold up the speaker here, which it would be louder if we were on a soundboard. Let me press it to a piece of cardboard here. And I'm going to play the outgoing message, which this is the one that was on it from eBay. Outgoing message play. Oh, see, this is what stopped working. Okay, I've broken something. This was playing outgoing message before. It has stopped, which is too bad. But let's, I'm gonna put this into the other one and play it back as if this was the message that had been left. Let's see if we can make it do that. So the play pause button was right here.
And I'll get right back to you.
So I'll stop that there. Let's pop it back up in here just to see maybe I had something turned off. Turn it off and on. Interesting, it did not try to rewind that, which usually it does right when it starts. Yeah, I've broken something. I don't know why. It's too bad. It worked yesterday, that part. Let's turn it back on. Play. Yeah, it just doesn't want to play that one. Don't know why. Then if an incoming message comes, it goes to this one. One thing I think we can do, so I'm going to rewind this bottom one. So there you can see the mechanism throw itself down here to try to rewind and get this one set for playback. And then you can record a memo, I think. Let's see. Hey, this is Lars. Uh-oh. So let's try to play that. So it rewinds. That's great. So it's got a little mic here that I recorded into. Whoa, yeah. So I of course I'm a little bit of a voyeur, so I checked the tape that had come in. There were, I think they had erased some incoming messages, so you could very faintly hear them. It didn't do a great job of erasing them, but nothing incriminating. No one said where the treasure is buried or anything like that. But I do love that the original outgoing message is still on there. I'm not sure why it doesn't want to play right now. I'm also not that familiar with the controls on it, so it could just be some user error on how I'm trying to play it. But anyway, I thought that was neat. That is, I may run some ribbon cable so that I can have this open and look at the mechanism when it's on there. I don't know if I have a convenient set of ribbon cables to do that with right now, so maybe I'll prepare that for next time. But that I thought was fascinating. That's this little Panasonic answering machine sort of working. Turn that off. Okay, so take care of that. And actually, let me stay. I'm going to stick over here, and I wanted to just show my next little fun project I'm going to be building just for myself, but it may turn into something CircuitPython related, which is this Eurorack module. I mentioned this last week. It had just been announced, and I ordered a kit from thonk.co.uk, and it came. So I wanted to show you what a kit from thonk.co.uk looks like and what I'm going to be building here. So Here's a ribbon cable for power, mostly Eurorack power. That's a little add-in. Here's a little Eurorack blank panel. So that's here. Free sticker, free button. Set that over here. So this is the front panel and PCB, rather the front panel, PCB-based front panel right here. What this is going to go into is a little Eurorack modular synthesizer, which I just so happen to have kind of exactly the space I need on this one. So this is a little Eurorack case I built and put into it a 2-oscillator VCO, voltage control oscillator voice, that can be a bunch of different signal shapes, waveform shapes, a dual voltage controlled amplifier, and I have a little overdrive module here. I still need some to rejigger that to put a envelope generator and maybe LFO or something in there. But this is going to end up being a control voltage and audio processing and generation brain that can use little bits of code to change its functionality. The kit here consists of some populated PCBs. Here's the main brain of it. I'm going to zoom in a little bit more there. So I have this upside down. Here you can see all the tiny components. It used to be in the older days of Eurorack kits, you were soldering everything on, and it was a lot bigger, and it had dual boards, through-hole stuff. But this has an RP2040 on here, so that's what's the brain behind this. Has a DAC, and it has some op amps and other circuitry for dealing with input and output voltage. The pieces and parts that you are going to solder into a kit like that will be jacks and knobs and potentiometers and that sort of thing. So you can see we're going to have a large knob there for control. There's a little SD card holder on here that actually does not hold SD cards, but holds these little program cards that are the EEPROM for the RP2040. This is one of the little program card sets with different programs kind of pre-built onto them. Here are some just nuts and washer hardware. These are potentiometers and LEDs. Jacks, potentiometers. I'm not sure if one of these is an encoder. Nope, that's a pot. Just a bigger pot. Some of these are little trim potentiometers. And a switch, I think, on there. A couple switches for mode selection. But these, if we look at these little blank 2 megabyte program card set, this is really neat. So these are where you can edit the code, and it's like removing the brain from your RP2040 based microcontroller and having everything else still here, but it can't do anything until you plug in one of these. And so it's as if you had code.py, and code.py living on 3 separate little boards, and just changing what it's going to do, restart it, and you're going to have whatever that function is. So there are a lot of these that are being made by members of the community. There's a few that RYK is selling as pre-made little cards, and then these are reprogrammable, and it comes with a set of them that are already programmed. But these are the ones that I'll get to program myself and change how this thing works. That was just the bag that it all came in there. So I think that's it. That's all the parts that I'm gonna need to put that together, and I might do that this weekend. So maybe have something to show next week and dive into it a little bit and get to do some programming on it. So also, I think Todd Kurt is working on a port of CircuitPython to this module particular module, so it could be used for all sorts of things. The DAC on it is a bit of a unusual one, so he's put a lot of work into getting this all working. So thanks for doing that. And that is the kit. I bought this myself with my own money. This is not, just so you know, me shilling for anybody. I love Tom Whitwell, the guy behind Music Thing Modular, super lovely guy, and the community around this, and Thonk. I think they're all great, but this is just my own little thing here, not getting paid for that, just so you feel good about it. All right. I'm gonna turn my AC back on because it got hot in here. Turn off the second mic. And let's see. Is that it? I think so. That's what I got. So a reminder, if you want to go get some things, you can head to adafruit.com and use that coupon code CTech-astronomy to save yourself a little bit of money. And very aptly in the Discord, some nice put together a little GIF. Interesting. What could it mean? Thought it was CTech Astronomy. So go rewatch Sneakers, and you'll appreciate what's going on. I think that's it. Let me just check the other chats. Where'd you go, YouTube chat? I keep losing that one. You are here somewhere. That's not it. I have so many windows. Hide that. There it is. Good. No, we're all good. Okay, thank you everyone so much for stopping by. I think there's going to be a deep dive with either Scott or Foamy Guy tomorrow. I think it's Scott tomorrow. And then there may be some Desk of Lady Ada, and watch the Adafruit socials for stuff over the weekend, including some of these very mysterious, cool things that PT is working on that warrant a Sneakers prop. I will be back on Tuesday with a product pick of the week. We will, I think, also have a Foamy Guy deep dive on Tuesday, earlier in the day. Watch for those. The 3D Hangouts Wednesday morning. Show and Tell Wednesday evening. Rinse, repeat. And I think that is going to do it. So thanks everyone for stopping by. For John Park, for Adafruit Industries, I'm John Park. This has been John Park's Workshop. Bye.